and welcome if you are new in here. Don't forget to click subscribe on button. Before I start this video, allow me to introduce myself. My name is Mariani Gress, and my student ID number is 1901070066 in majoring Mathematics Education in Nomechan University, Pematang Siantar. Alright, in this video, I'm going to prove that derivative of cosine is equal to negative sine. So, let's jump into it. Proof. So to do the proof, we are just going to show that derivative exists and that it's equal to negative sign. Recall that if you take the limit as h averages 0 of the different equation, so f of x plus h minus f of x all over h. So if this limit exists, you say the function is differentiable at x, and we say the derivative is equal to result, and we call that f prime of x, and that's called the derivative of the function. So all we have to do in this problem is compute this limit and show it's equal to negative sine x. I'll start by writing that limit down, so I'll write it again. We have the limit as h averages 0 of f of x plus h minus f of x all over h. Now, our f of x in this problem is cosine x. So f of x plus h is simply going to cosine of x plus h. So we have cosine x plus h and then cosine x. Because our f of x is cosine x, so you just plug in x plus h to get this part. It's all being divided by h. At this point, really the only thing we can do is use an identity over cosine of x plus h. Let's do it. I'll write down here this limit as h averages 0. So you can use if it's called the sum identity, so it will be cosine x, cosine h. Then it's minus, and then it's sine x, sine h. And then we still have the minus cosine x. And it's all being divided by h. All we did was use an identity here for cosine x plus h is just cosine x cosine h, and then minus sin x sin h. So there's two limits that before you learn about derivatives. The first one, I'm going to use h instead of x as h averages 0 of cosine h minus 1 over h. So you get 0. And the other limit is the limit as h averages 0 of sine h over h, and you get 1. So the goal here is going to write down what we have using this limit. So let's look here. We have cosine x cosine h and then minus cosine x. So we can pull out a cosine x from this and we'll get cosine h minus 1, which is precisely what's the top of this limit here. So let's do that. So this is equal to the limit h averages 0. So I'll put out the cosine x, and then we will have cosine h minus 1, and it's all over h. And then here we have minus sine x minus sine h. So we can take this part here and write it like this. So this would be minus sine x times sine h over h. So this piece here was grouped with this piece here, and it's all over h. And then this is the middle piece is over here. Alright, so this is equal to, well, this limit is 0. You get cosine x times 0 minus sine x, and this limit here is 1, so the times 1, so that's 0 minus sine x, so that's minus sine x, and that's proof. Alright, I think until here for today, and thank you for watching, and goodbye.